So this is a chapter in this course that gets a little bit tricky. Biomechanics is going to utilize terminology related to physics, and physics is kind of a scary word. If you've had physics before, again, it will be helpful. So this is the portion of kinesiology where we need to learn a little bit more about physics. If you've had a physics class before, this is really going to be helpful. Physics is important to know and understand so that we can describe how the body moves and describe the forces that actually impact the ability of the body to move. When we think about terms that relate to movement, we use the terms static or dynamic. Statics are non-moving or almost non-moving types of systems, and dynamics are things that relate specifically more to those things that are moving and moving systems within the human body. There are a couple of terms your book describes. Kinetics are the forces that cause movement, and so we're going to learn some more about that in just a moment here. Kinematics is a word to describe a variety of different things that impact a moving system, like the amount of time it takes to move through maybe a specific range of motion, the space, the mass of the moving system. So we're going to learn more about those. When we think about kinematics, there are osteokinematics. Those are the things that impact the movement of bones, a bone-on-bone type of movement. We've already learned a little bit about arthrokinematics, which is the movement that actually occurs at the joint surfaces. More about motion and specifically what causes motion. We're going to spend quite a bit of time talking about the word torque. It is going to be important that you understand this definition. Torque is a force that creates rotation around an axis. So when we think about most of the joints in the body, they are going to be affected by a rotational type of force, which is referred to as torque. Friction is another term that we use more specifically to prevent motion, to restrict motion. And there are a number of different ways that your book helps to define what friction might be like in terms of the effect of motion. Now let's talk about the laws of motion. You're probably familiar with Isaac Newton and Newton's laws of motion. There are three laws of motion that we are going to apply to the content that you're going to learn in this course. So these are important for you to have some general understanding about. The first one is called the law of inertia, and you've heard of this one probably through commercials that you've heard. For instance, a body at rest stays at rest, and a body at motion stays in motion. This can be probably best applied to a moving car. As a car is moving forward and say hits a stationary car, the car that's in motion, or the contents of the car specifically, want to remain in motion. So if you're not seat belted in, your body's going to want to continue to remain in motion and throw you forward, potentially out of the front windshield. If you don't have your seatbelt on, all of your contents in your car continue to move forward as well, so everything falls towards the front of the car or onto the floor. The second law is called the law of acceleration, which basically says that the amount of movement forward, acceleration forward, depends upon the strength of the force that's applied to that particular object. So the best example to explain this would be to kick a small ball on the floor forward. If you pull your foot back slightly, bend your knee slightly backwards, and kick the ball, you'll notice that the ball will move forward. If you take your leg and bend it more significantly backwards, and kick it with more force and strength, what you'll find is that the ball is going to move further forward. So that's the law of acceleration. The last law is called the law of action and reaction. Again, this is one you've probably heard pretty frequently. For every action, there is an equal and opposite reaction. Probably the best example of this would be jumping on something like a trampoline. The harder you jump down, the further up you go. So if you jump lower, you're going to bounce higher. And so that is the law of action and reaction. Newton's laws of motion are laws that help to explain movement. There are three important characteristics that affect forces, and you can find that information in your textbook on page 105 or figure 8-2 if you look at that figure. Those three characteristics of forces are magnitude, direction, and point of application. So magnitude is essentially how hard the force is being applied. So if you see the image on figure 8-2, you'll notice that each person is pushing equally hard on this box or this object. The direction then is shown which way the force is being applied. So you can see where force A is moving the force towards the right, and force B is moving the box, using force to push the box in an upward direction. We're going to talk more in a moment about what the concurrent force occurs and what we call a resultant force in just a moment. The point of application would be where you're pushing on the box, and in the case of this figure, it is showing that each person is really applying similar, if not exactly the same, distance between their arms and how they're pushing on that specific box. In thinking about how forces are applied, your book describes something called linear force. And if you look in your textbook on page 106, you can see figure 8-3 showing two different types of linear forces. The first one, where you can see the two people pulling a boat, these are forces that are acting on the exact same line in the same direction. And the other example, B, is when two people are actually pulling in opposite directions. Now, a parallel force is identified on figure 8-4, and you can see that a parallel force is applied here in terms of describing how a back brace would work. Basically, you've got your X and Y forces pushing towards the back of the person, and you've got your Z force pushing towards the front of a person. This is a parallel force, which is another linear type of force. Now, we already looked on figure 8-2 at a concurrent force. So we had two forces pushing or pulling in different directions. So we had one person, force A, pushing to the right, and force B pushing up. Showing what is termed as a resultant force. If you look at figure 8-5 on page 106, you can see that what happens here is the movement does not occur in an upward direction. It does not occur in a direction towards the right, but it actually falls somewhere in the center of that, creating more of a diagonal force towards the right and an upward position at the same time. Those are linear forces, and that resultant force is also something that we are going to be able to describe when we think about some muscles occurring. We have a couple of muscles creating a force at the same time in two different directions, which create a resultant force. If you look at figure 8-6 on page 107, you can see the three deltoid muscles. We have an anterior deltoid, a posterior deltoid, and right in the center of that is the middle deltoid. Now, the really cool thing about this is if the anterior deltoid and posterior deltoid both contract at the same time, we actually get a nice smooth motion of abduction, which is what the middle deltoid is responsible for. Again, the cool thing is if the middle deltoid for some reason were taken out and wasn't able to move, it is a prime mover for shoulder abduction, but we could contract the anterior and posterior deltoids at the same time. We can still create shoulder abduction through the use of that resultant force. So I think that's pretty interesting and neat to to see. Now, in looking at linear forces, we also have something called a force couple, which creates more of a rotational type of turning effect. There's a nice picture on page 107, figure 8-8, shows a couple of people pushing a merry-go-round at a playground. What you can see is that these people are moving in two different directions, actually creating a turning effect. And we're going to learn more about force couples when we hear about how the scapula works. It's also a good example of a force couple is when you take your fingers and put them on the top of a jar and you push the force on your finger side towards the left, and on your thumb side towards the right. It creates a turning effect. This next description about torque we are going to do in class. This is very difficult to explain to you through an audio file. It would be a good idea for you to take a look at figure 8-11 on page 108, and also to study the information on torque in your chapter on pages 107, 108, and 109 before you come to class. For understanding the content about stability, we will again go over this in class. It is important to know and understand sort of the definitions of a few terms. A state of equilibrium is when something is balanced. The center of gravity is the point in your body where all three, what we're going to learn, are called planes, where all three planes in the human body intersect. That is just in front of, just anterior to the second sacral vertebra. So we will be looking at that a little bit more carefully and really describe how some things can actually affect that center of gravity. Things like a loss of a limb that can actually move that center of gravity away from that particular point. A base of support is any part of an object that is in contact with another surface. So we're going to look at that as well as you think about sitting in your chair. What parts of your body actually are in contact with other surfaces, and as you may guess, the more base of support that you have, the more places where parts of your body are in contact with other surfaces, the more stable you will be. We're going to talk about stability. The line of gravity. The line of gravity is an imaginary line that goes directly through the center of gravity towards the ground. So we're going to talk about how moving that line of gravity forward or backward away from the center of gravity actually produces instability. So we're going to talk in class about what stable equilibrium looks like, what unstable equilibrium looks like, and how neutral equilibrium is when you're neither stable or unstable. We'll talk more about that.